Hey guys, welcome back. We're still here at the joiner. We're going to talk about some safety concerns and some safety issues with this machine. We operate in our shop with our 4-inch rule, which says we're not going to put our fingers closer than 4 inches to any moving cutter head. And we've talked about some exceptions on a couple of different machines. The joiner is not one of them. We never want our fingers closer than 4 inches to this cutter head. In our overview video, we took a close look at the cutter head, the way it rotates, and the risk that it poses in terms of pulling your fingers in as it's cutting them. It's really critical on this machine that we keep our fingers away from this cutter head. And we have a couple of things in place to help us with that. So the first thing is our guard. We never operate the joiner without the guard. It's too much risk. It exposes us to the cutter head. It's a chance that we're not willing to take at this machine. So the guard will always be in place. And as you saw in that overview video, the guard allows us to easily push our material in the correct direction, but it prevents us from accidentally running it the wrong way. We're always going to run from in-feed to out-feed against the rotation of the cutter head. We never run material in the same direction as a cutter head. We've got our guard that is going to help us. Just a reminder, this guard will protect me if I lose my balance and I go to put my hand down right here. It will prevent me from putting my fingers or my hand down on top of the cutter head. But if my finger is down along the side, and we saw this in our overview video, if my finger is down along the side, this guard is going to just move right out of the way and allow me to put my finger in down by the cutter head. So I've got to keep my fingers up away from that cutter head. The tools that we're going to use to do that are push sticks. And we've got a couple different styles, and we've got some rules at the joiner as to when we're going to use our push sticks. So the two different styles that we have, this is a short version of just our standard push stick. Holds like this, and it's got a little hook on the end that allows us to grab onto the back of our material and push it through. And it creates good spacing between our hand and our fingers and that cutter head down below. The other one that we have is this one. It's more of a wooden pad style sled. Same little mechanism on the back to grab onto our material. But this one allows us to put pressure along a greater surface. So if we were jointing a face of a board, this push stick here is going to allow us to cover that board better and get pressure along a greater length of the board as we're running it through. What are our rules for when we use push sticks? We always use a push stick when we're jointing the wide face of a board. I will never come to the joiner with a piece of material like this and let me slide this back a little so it fits and put it down like this and attempt to run it through. This is much less than 4 inches of distance here. Extremely dangerous. If I were to slip off of this board as I were running it through, I'm going to get my fingers caught in this machine. So anytime we're running a face of a board, we are always using a push stick like this to protect us as we run it through. Now, when we're jointing the edge of a board, okay? If this is my board and I want to joint this edge right here, you can see that this board is shorter than the fence. If my board is shorter than the fence, I have to use a push stick. Okay? I don't want to be running my material like this. Again, these fingers are far too close to the cutter head on this machine if I don't use a push stick. So in this instance, I like to use 2 of these, and I'm going to put one up towards the front and one at the back, and this is going to allow me to apply pressure to my piece as I run it through and keep my fingers away from that cutter head. Now, what if my piece is taller than the fence? you can see this piece of material is taller than the fence. I do not want to use a push stick in this case. The reason I don't want to use a push stick is if I set my push stick on top of my piece of material here, it's difficult for me to keep the push stick in a consistent position. And so in this case, when our material is taller than the fence, we are not going to use a push stick. I'm going to show you right now from a different angle the correct hand positioning to make this cut. So in order to make this cut with the piece of material that's taller than the fence, I'm first going to take my left hand, which is my lead hand, as I'm running my material through here, and I'm going to put it up near the front edge, and I'm going to set my fingers so that they're pressing in towards the fence right here near the top edge. And I'm going to grab on with my thumb just like this for stability. My right hand is going to go at the back edge with my thumb up on the corner of the piece and my fingers on top to give me a nice stable positioning. Now with my hands in this position, now I can start sliding through. And the reason these fingers have to be pushing in against the fence is that the cutter head cuts square to the fence. And so if I'm not holding my workpiece tight against the fence, then I'm going to end up with a bevel or an angle cut along the edge of my board instead of it being perfectly square. So these fingers, again, pushing right in, right at the top of the fence, my left thumb holding onto the top of my board, and my right hand providing the power through. Now, once my left hand, this goes for any cut, but I'm going to demonstrate it right now. Once my left hand gets to the back edge of the guard, I'm going to start pushing down pretty hard with this hand because I want this clean, newly cut edge right here to be tight against the outfeed table. I want my material tight against the fence, and I want the cutter head to cut the remainder of the edge or the remainder of the face parallel with that. And so I'm going to transfer my pressure to the outfeed table as I finish running my piece through. Let's talk about minimums and maximums. Maximum width and minimum length. Just like our planer, those are the two restrictions that we have on material size when we're running our material through the joiner. So our minimum length, the shortest material that we can run through here, is 9 inches. It's got to be 9 inches so that we've got enough material contact with the infeed and outfeed tables for you guys to maintain control of your pieces and to be safe. So that means, just like at the planer, if you need short pieces, you may have to cut them long in order to be able to achieve the size that you need. Or if you need multiple 4-inch pieces or multiple 5-inch pieces, we're going to square up one board and then go to the radial arm saw and cut it down to length. So 9-inch minimum length. There is no maximum length. The longer your piece gets, you may need some assistance from a classmate, or we may need to set up a roller table to help support the material as it comes through. When we talk about maximum width, the two joiners that we have in our shop have 8-inch cutter heads. And so 8 inches is the maximum width that we can run. Oftentimes, if you are working with wider material, we're going to want to cut that down into smaller pieces and glue it together for stability anyway. But the maximum capacity on joiner in terms of width is 8 inches. So those are the primary safety concerns that we have at the joiner and how we are going to deal with some of those concerns, making sure we're keeping our fingers away from that cutter head so that we can be safe and have a good result when we use this machine.